So I wanted to talk about a few of the things that we didn't have time to talk about in class yesterday. So I'm going to be looking at the notes. And the first one here is number 34. We looked at it one way where we said, well, what if we get a log base 3 on one side and a log base 3 on the other side? Then we can just set the arguments equal. But another way to do it would be to get all the logarithms on one side. So I would have the log 3 of x minus 2 log base 3 of 5. Then I would subtract the log base 3 of x plus 1 and add 2 log base 3 of 10. And now I would have 0 on the right-hand side. So I know this is going to be log base 3 of x minus log base 3 of 5 squared minus log base 3 of x plus 1 plus log base 3 of 10 squared equals 0. So that's going to be log base 3 of x over 25. Then I have minus log base 3 of x plus 1 plus log base 3 of 100 equals 0. So I'm going to come over here and continue. So I know that if I have a minus a log, that needs to go in the denominator, the argument. So I'm going to have log base 3 of x over 25, and now an x plus 1 in the bottom also, plus log base 3 of 100, and this is still equaling 0. And now I have a sum of logs, so I'm going to have 100 times x over 25 times x plus 1 in my logarithm. Sorry, this is log base 3 of x of 100x over 25 times x plus 1, and that has to equal 0. So now I write it in exponential form. I say 3 to the 0 equals 100x over 25 times x plus 1. But 3 to the 0 is 1. So do you see how we get to the exact same spot of algebra work as we did doing it the other way? So now we'll have 25 times x plus 1 equals 100x. So 25x plus 25 is going to equal 100x. So 75x equals 25, and x equals 1/3. So you can try it either way and see which way you like better. So I also wanted to talk about number 40 and see that, oh, this is another one of those quadratic in form, because I have something here and I have that same thing to the power half as big. So here the exponent is 1, here the exponent is a half. So if I let w equal the square root of the ln of x, then w squared is going to equal ln of x. So then we can rewrite number 40 as w squared minus 3w plus 2 equals 0. And say, oh, this is one we know how to do. I'm going to have w minus 2 and w minus 1 equaling 0. Then by the zero product property, we know either w minus 2 equals 0 or w minus 1 equals 0. So w could equal 2 or it could equal 1. But remember, when we're at this spot, we're at maybe. We have to check. So now let's go back and see what w equaled. Well, it equaled the square root of ln x. So now let's check w equal 2. So I'm going to say, what if 2 equals the ln of x in a square root? So w equals the square root of ln x. If I square both sides, I'm going to get 4 equals the ln of x. Then solve for x by writing an exponential form and have e to the 4th equals x. So that's one of my answers. So then let's check w equals 1. So if I have 1 equals the square root of the ln of x, and I square both sides, I get 1 equals ln of x, so e equals the other value of x. So x equals e to the 4th, or e, and both of those are perfectly good inputs because the input to a log has to be positive, and these are both positive numbers. So let me know if you have questions about that one. Then the other ones I wanted to look at were these quadratic in form. So now we've kind of done a quick review of quadratic in form. So I want to show you some more examples. So this first one, see how the exponent here is twice as big as the exponent here. So let's let w equal 3 to the x. Well, then w squared is going to equal 3 to the x times 3 to the x. And we add the exponents, so that's w squared is 3 to the 2x. Oh, so now I can rewrite this as w squared plus w minus 2 equals 0. And I'm not working on this one yet. So this is a problem we know how to do. W plus 2, w minus 1. Double check your factoring always, but that looks like it works. So then I'll have w plus 2 equals 0, or w minus 1 equals 0. So w might equal negative 2, or w might equal 1. Well, let's check w equals negative 2. So this is always maybe when you get to this point on a logarithmic problem or exponential problem. So testing w equals negative 2. Well, that would mean negative 2 would equal 3 to the x. Well, we know the graph of 3 to the x looks like this. Can you ever get a negative number for the y value? No. So this never happens. And apparently w equals negative 2 is not a good solution. It's an extraneous solution. So let's see what happens if we have w equals 1. Well, now we're saying 3 to the x equals 1. So we're saying what power should we put on 3 so that we get a 1? And hopefully by this time you've practiced enough that you're saying, oh, I should have 0. 3 to the 0 is going to be 1. So my answer is x equals 0, and I can check by saying, well, is it true that 3 to the 2 times 0 plus 3 to the 0 minus 2 equals 0 from my original equation? 3 to the 0 is 1. 3 to the 0 is 1. So it checks. So my answer is x equals 0. So now let's look at number 60. And you can see it's similar but not exactly the same. I have 2 to the 2x plus, do you agree with me that I could rewrite that middle term as 2 to the x times 2 to the 2? And if you're not seeing why, review your properties of exponents. When I have matching bases, the exponents add. Well, if the exponents are added, I can use the property in reverse and write it with two separate bases. Then I have minus 12 equals 0. Well, now I'm going to let my w equals 2 to the x. So w squared is going to equal 2 to the 2x. So I have w squared plus, now I have 4w minus 12, because this 4 is not part of the exponential function that we let stand for w. So now I'm going to have w plus 6 and w minus 2. Double check my factoring. It looks good. So w plus 6 equals 0, or w minus 2 equals 0 by the zero product property. So w might be negative 6 or 2, and we have to check. So test w equals negative 6. Well, again, can negative 6 ever equal 2x? No, this never happens. You can never get a negative number out of a basic exponential function. So now let's look at w equals 2 and say, well, that would be 2 equals 2 to the x. Well, I can see that x would be 1 then. So let me check and see if 2 to the 2 times 1 plus 2 to the 1 plus 2 minus 12, does that equal 0? Looks like 4 plus 8 minus 12. Yep, it works. So I feel good about my answer of x equals 1. So now let's look at number 67. And you can try this one, but let's first talk about, oh my gosh, I have an x and a negative x. So the very first step on this one is you're going to need to multiply everything by 4 to the x to get it to look like the problems we've been working on. So you'll have 3 times 4 to the x on the right. So now when you work on this problem, you're going to say, oh, 4 to the x times 4 to the x is 4 to the x plus x, or 4 to the 2x, minus 10. 4 to the x times 4 to the negative x is 4 to the 0, which is 1. And that's going to equal 3 times 4 to the x. So now I need to subtract the 3 times 4 to the x from both sides. And then you do your same trick of let w equals 4 to the x. So I'm going to have w squared minus 3w minus 10 equals 0. And I'm going to let you finish solving. So let me know if you still have questions.